probability distribution. A young couple decides to try to have children until they have a boy. For financial reasons, the couple decides that they are going to stop trying when they have 3 children, whether they have a boy or not. We are assuming that having a boy or a girl is equally likely, and that the child's gender in each birth is independent of the gender in the other births. Let the random variable x be the number of children the couple has. What is the sample space S in this case? In other words, what are the possible outcomes in this case? Use B for boy and G for girl. The key phrase here is that they are trying to have a boy, but they stop when they have 3 children. And so we interpret this as if they have a boy, then they stop because they already have a boy. Or if they have the girl the first time, then they can try again, and if the second child is a boy, then they stop. However, if they have the girl the first time and then the girl the second time, then they would try again. If they have the boy the third time, they stop. Now, this is the lot unfortunate case for them, but it is possible that they have all 3 girls. But again, even though in this scenario they do not have a boy, but for financial reason they stop. And so the sample space lists 4 possible outcomes only. The first outcome, boy, when they have 1 child and they have a boy. The second outcome, girl or boy, they have a girl the first time and a boy the second time. They stop. The third outcome, girl the first time, girl the second time, and boy the third time. They're lucky. And then the last one is when they have no boy, but again, they need to stop because of financial reason. Part B, using the simple principle of probabilities, find the probabilities of each of the outcomes listed in the previous. The probability of the outcome B is simply 1/2. The simple principle of probability, because we assume that having a boy or a girl are equally likely. For the second outcome BG, because we assume independence of the birth, then this is the probability of G times the probability of G, which is 1/2 times 1/2. This is 1/4. The probability of GGB, again, we assume independence, so this is the probability of getting the girl the first time times the probability of getting the girl the second time times the probability of getting the boy the third time. So this is 1/2 times 1/2 times 1/2, or 1/8. And lastly, the probability of GGG, 3 girls, is probability of G girl the first time times the probability of G girl the second time times the probability of G girl the third time. And this is 1/2 times 1/2 times 1/2, which is 1/8. So we found the probability of each of the outcomes that we listed in Part A. For Part C, write down the value of the random variable x that is associated with each of the outcomes. But what is x? Recall that x is the number of children the couple has. And so for Part C, for the first outcome, x is the number of children, so x equals 1. For the second outcome, x equals 2. And for the third and the fourth outcome, how many children are there? 3. We only list 3 once. Using what you found in the question above, summarize the probability distribution of x in a table. And so in a table probability distribution of x, we list the value of x with the corresponding probability x equals the lowercase x. The possible values of x are 1, 2, and 3. 0 is not included in this case because there is no outcomes with 0 child at all. The probability when x equals 1 is the probability of boy, one child only, and that is 1/2. The probability when x equals 2, 2 children, is 1/4. The probability that they have 3 children, there are 2 cases, each has a probability of 1/8, and 1/8 plus 1/8 is 2/8, but 2/8 is 1/4. And so we have P of x equals 3 equals 1/4. And we can double check that each of these probabilities is a number between 0 and 1. And if we add 1/2 plus 1/4 plus 1/4, then the sum is precisely 1.